Hello. The purpose of these warm-ups is to help us to review for finals by just giving us quick pictures of things that we have done this semester. So our goal for these is that you kind of recap, oh yeah, that's what we did, and you feel good about it. So with these, I would recommend that you try all of the problems first without looking back at your notes and without watching the video. So try all of these problems and see what you get. And then after you have tried them all, you can go ahead and listen to the video and see if you did them right. And if not, there is space down below so that you can redo the problem. Don't erase your work, but redo the problem and write notes to yourself on what happened. So after you have given each of these a good try, go ahead and come back to this video and finish up with watching how you do them. Okay, number one is in slope-intercept form. So we are going to begin by graphing 1 on our y-axis and a slope of -3. So we're going to go down 3, right 1, and up 3 and left 1. And if you connect those points, that's what the graph should look like. Number two, this is in standard form. So it's important to be able to recognize what form it's in because you might need to be able to graph from that form. For this one, you have a couple of options. You can find the x-intercept and the y-intercept and graph them, or you can put this in slope-intercept form. So that's the what I'm going to show for this one because I think that's where a lot of us go for the first when we see this. So we move the 2x to the other side, and then we divide by 4, and we get y equals -1/2 x plus 3. So looking at this, our y-intercept is up at 3, and our slope is down 1, right 2, making it -1/2. So you graph your points, and then you connect them, and this is what number 2 should look like. Now, number 3 here, you do have a couple of options. You can put this in slope-intercept form, but if you have already tried that and gotten stuck on this one because your y-intercept was 30, you might be saying, well, we can't even graph this one, but we can. The problem is we cannot graph it in slope-intercept form, but we can graph it in point-slope form. So point-slope form is y minus y1 equals m times x minus x1. So your slope here is going to end up being 4 for this one. And the points that got plugged in, you're going to take whatever's with x, and you're going to flip it from the +7 to the -7. And you're going to take whatever's with y, and you're going to negate that as well. The point that got plugged in was -7, 2. And why that helps us is now we can graph the point -7, +2. That's a point we can graph. And we can now do our slope of 4 from there. And as you can see on your graph, it's way off on one side here. And if you imagine continuing and extending this, it would back up that your y-intercept should be 30. So if it's in point slope form, try to graph it a different way. Our next one only has an x, so what we can do is we can add 3 to both sides and get x equals 3. And if you were to graph that, any x equals is always going to be a vertical line through the x-axis at whatever number is there. So you can go to 3 on the x-axis and draw a vertical line through there. The next one is very similar. When you add 4 to the other side and then divide by 2, you end up getting just y equals a number. We get y equals 2. If it's y equals a number, it's going to be a horizontal line. It's going to go through the y-axis at whatever number it is. So we end up graphing a horizontal line through 2 on your y-axis. So that's a quick recap on graphing linear functions. Thank you for listening.